My problem is, can I build a railgun to launch an armature using electricity and magnetism? Railgun research is most commonly performed by the military due to their ability to launch projectiles at a higher velocity with lesser susceptibility to wind resistance and bullet drop. However, researchers still need to find a way to generate enough electricity to power the railgun and prevent the rails from belting or deforming after the gun has been fired several times. A railgun uses electromagnetic propulsion to drive an armature along a pair of conductive rails. In my experiment, I designed 3 prototypes. The first prototype, which consisted of an armature made from a rod, washers, nuts, and bolts, failed due to the lack of inclusion of magnets. The second prototype, which used 2 neodymium magnets and a hex bolt, resulted in the armature spinning in a circle rather than rolling down the rails due to the magnetic poles facing the wrong way. Once I aligned the magnetic north poles facing inwards, the third prototype was successful in moving the armature down the rails using a 6-volt and 12-volt battery pack, but unsuccessful using the 1.5-volt and 9-volt batteries. Further testing using a 1.5-volt, 6-volt, 9-volt, and 12-volt power supply helped me conclude that the current levels of 4.82 and 6.39 milliamps produced by the 6-volt and 12-volt battery packs were able to move the armature, while the levels of 1.56 and 1.6 milliamps produced by the 9-volt and 1.5-volt batteries do not produce enough force to move the armature down the aluminum foil rails. If I were to conduct this experiment again, I would like to either figure out the lowest amount of current needed to move the armature, replace the batteries with capacitors to see how much force I could apply on the armature, choose a different conductive material as rails, or add a device to keep the armature on a straight path as it's rolling.